Okay.
Hello.
Hello.
Hi, Thomas. Or do you go by Tom?
Hey, either one's fine. How are you,
Okay.
Karen?
I'm good. I didn't
Okay.
when I logged in, when I signed in to use my phone for audio.
You did or you did not?
Did not. I didn't get that option.
Oh. Well. Not sure what to do about that. I think we will just have to run with it and hopefully it works.
Okay. How's my voice now?
You're pretty good. One thing we can do, since you're going to be sharing your screen, if you want to shut your video off, it just turn off the video and just use your voice in the screen share. That may help conserve some bandwidth.
Okay. Okay.
So that's my best suggestion.
Okay. Sounds good.
All right. So you're all set to go?
Yes, I am.
Okay. I am looking at the waiting room right now and I see 10 people in there. We've got about 4 minutes here. I'm going to give them right up to 6:30 before I admit everyone and then start the presentation. I've got about 10 minutes maybe tops of stuff to kind of go over for the group. And then I'll kick it over to you as host. And when I kick it to you, I'm going to go ahead and turn off my video so that nobody's looking at me while I'm kind of taking my own notes and things. And then when you're done, I'll go ahead and take that back as host, turn my video back on, and be able to ask you questions at that point.
Okay.
And I'll leave you unmuted. You're the only one that I may have unmuted other than myself.
Okay.
Okay?
Yep, that sounds good.
All righty. So just hang tight for a few minutes here.
Okay, sounds good.
Thank you.
We could probably do this. Too much of a glare.
Yeah, that looks real good right there.
Yeah, I thought I couldn't see. Too much of a glare from the window.
Yeah.
Okay.
I'm really grateful I've got an iPad. It allows me to do that virtual background. I don't have to worry about that glare so much.
Oh, yeah.
We're up to 13 people in the waiting room. That might be the biggest audience we've had in quite a while.
No kidding. Oh my gosh. Wow. Maybe you should do video conferencing more often. You know,
I would like to.
Yeah.
I think it works out well, but this is the first time we've tried it in our group. So other sections do them all the time.
They do.
We just, yeah, we just haven't traditionally done them. We normally get about 8 to 10 people in a meeting. If we're on campus, we'll get more like 15 just from the students. But to not be on campus and get this many is pretty good.
Yeah. Crap.
Go away. There we go. All right, that's kind of my cue. It's 6:30, so I'm going to let everybody in here and we'll get going.
Okay.
All right, good evening, everyone. My name is Thomas Sholty. I'm the chair of the Lafayette section of the American Society for Quality, ASQ. I want to welcome all of you to the very first Lafayette section virtual meeting. To my knowledge, we've never done a virtual meeting before. So this is kind of new, it's kind of exciting. Hopefully everything's going to go well tonight. Glad to see all of you jumping in and joining us on this meeting tonight. I'm going to take a little bit of time here right at the beginning to cover some things that are going on in ASQ and in the world in general with the COVID-19 response and all that. First and foremost, for anybody who hasn't heard, the World Conference on Quality Improvement, WCQI, scheduled to be in Columbus, Ohio this year, has been canceled. Unfortunately, that's just kind of where we are with this world, where we are with things going on. And it had to be done in order to protect everyone and try to further that response. The good news with this is there's now a scheduled WCQI virtual event. That was just announced here in the last week and a half. That's scheduled to be on Wednesday, May 6th. It's going to be free to all ASQ members, and I think that's really cool. It's really important here because, you know, not everybody could travel to Columbus, Ohio. Not everybody could afford to attend that live event. This event's going to be free to anybody who's a member. So if you're not an ASQ member and you're joining us tonight, think about joining, think about paying that membership fee to be able to attend this online event. There's going to be 2 live online keynote speakers and then 40 on-demand sessions that will be available for an entire week starting May 6th through May 11th. Gives you plenty of time to get in there, dig into some of those topics and learn some new things. The kicker to that is you have to register for that event. It's not something that you can just jump in at the last minute and attend. You do have to register in order to be able to do that. Having said that, if you are an ASQ member, you should have received an email sometime in the last week. I got mine last Friday, so should have come in the last week or so, asking you to register for that event, offering you the opportunity. If you haven't seen that email, if you haven't registered yet, you do need to do that. If you haven't seen that email, go to myasq.com, go ahead and get registered for that event. And while you're there on ASQ.com, check your settings in your profile just to make sure you're getting the right emails. Another big thing from ASQ National, they have extended membership benefits, an extra 2 months for anybody who's expiring soon. So you get an extra 2-month grace period to pay your annual membership dues. That's going to be important for some people who have been unfortunately put out of work or laid off. You know, we want everybody to be able to participate in ASQ, and unfortunately, some of us just don't have the funds to do that at this moment. So this extra grace period for 2 months gives us time to kind of get our feet back under us and get things back in the swing of things. And there'll be no loss of benefits during that time. It does not extend your membership time. So when you do renew, you'll be renewing to the same expiration date, but it just gives you that extra 2 months grace period. ASQ National has also said that they don't want any in-person meetings happening from any section, any group until at least September 1st. That includes leadership meetings. So just so you know, the local Lafayette section leadership team, we are meeting virtually from time to time. We're talking with each other on the phone, via email. We are keeping up and we're working on things. And part of that is we're trying to come up with presentations for May and August. So if you know somebody who wants to do a virtual presentation for one of those, or you're interested in doing that, reach out to us, let us know. We would love to have you. ASQ staff, the headquarters staff, is also working remotely like most of us here locally are. So they're working from home. So if you have business that you need to get a hold of somebody there, go ahead and email them, go ahead and call their regular line. Those lines are being forwarded, or they've got voicemail set up, and they're checking their emails. They'll get back to you, it just may take a little longer. All their business travel has been canceled as well, or the vast majority of it, heavily restricted at least to very important business travel, very necessary. And last time I checked, all the testing sites are still closed. So if you've got a test that you're getting ready for, plan on going for a certification, just be aware those testing sites have been closed. You want to verify that they're going to be there for you when you're ready to go. Don't just go driving to the test site thinking your test is so good. So that covers pretty much everything from national and local that I want to make sure everybody knows about. If you have any questions, there is a chat option available here on this Zoom platform. So just find the chat box and you can type those questions out to everyone so we all see them and we'll get you some answers. Along with that, I want to introduce tonight's presentation. It's going to be on quality core tools. So if you need proof of attendance for your certification or whatever, or to prove to your employer that you attended, however, whatever you need for that, go ahead and open that chat window. But instead of sending it to everyone, select host only and enter your email address there. I'll be happy to get you a verification of attendance. We'll get that out to you within 1 week of the program. So by next Tuesday night, you should have that in your email. We will record tonight's program. I'm hoping to get it on the My ASQ page for our Lafayette section. Can't guarantee that. There are some size restrictions and such things that we're trying to work through, but we're going to try to get it on there as soon as we can, at least. So with that, I'd like to introduce Sharon Oman, a quality improvement specialist with Purdue Manufacturing Extension Partnership, Purdue MEP. She's going to give us tonight's presentation on quality core tools. So Sharon, let me throw hosting duties over to you here.
Okay.
And you should be all set to go here momentarily.
Okay. All right. I'm going to stop my video. And I'm going to share my screen. Okay. Do you see my screen, Tom?
I do.
Okay, and you can hear me okay?
I can. You're good to go, ma'am.
Okay. All right, just want to make sure. Okay. All right, so our presentation tonight is going to be about the quality core tools. I don't know how many organizations here are automotive based, so this is going to be very basic information for you because you're already using all these core tools. But if not, if you're new to, if you're not in the automotive industry, then some of these tools might be somewhat new to you. So this is just a very basic overview course for just to give you a brief presentation on each of the 5 quality core tools plus control plates. So a little bit about myself. I am a quality improvement specialist with Purdue MEP. I'm also a Purdue grad. I've got a bachelor's of science degree in mechanical engineering. I've got about 25 years of manufacturing experience. I've worked at GenCorp Automotive, and they used to have locations in Wabash, Indiana, Peru, Indiana, and Logansport. I've worked at all 3 facilities there when I first started working out. And then we went through some buyouts and we ended up as Trailerborg Automotive, and through all these buyouts and how buyouts go and mergers go, you get shifted into different roles, which was a good thing for me. So I started off as a product engineer right out of college. And then I became a program manager, and I was a process launch manager for a while, and ended up being a quality engineer at Trelleborg. And then I decided to take on a quality manager's position at Small Parts. So that gave me, before I was all automotive, everything I knew was automotive. So I understood ISO TS 16949. But then when I went to Small Parts, I got into just seeing what the ISO 9001 quality management system would look like. Small Parts, they supply to both automotive and like the consumer appliance industry and the consumer appliance and electrical division. So, and automotive. So that gave me a good feel for ISO 9001 and IATF 16949, which is what the quality management system is now for automotive. So I do training on ISO 9001, internal auditor training for ISO 9001, IATF 6949, and AS 9100. I also do implementations for those 3 quality management systems. So that's basically the realm of my, my job description with as a quality improvement specialist at Purdue MEP. And I also do the core tools classes when they come up. All right, so Purdue MEP, I'm not sure how much background or information you have on Purdue MEP, but we are a division of Purdue's Technical Assistance Program. We hire subject matter experts from a wide variety of industries and manufacturing business sectors throughout the state of Indiana. We only work with businesses within the state of Indiana. Each state has their own MEP center. So Purdue hosts Indiana's MEP center. And then also, so what we do exactly is we go to these Indiana businesses and we help them streamline their processes, help them increase profitability and their competitiveness. And we do this by offering public workshops. We also do on-site training. I think those are the most impactful when we actually get to go on site and help our clients with quality management systems, or if they have an issue, maybe they have a flow issue, or they just want some productivity improvements. So we can go on site and help them with these services. So these services gain impact for us based on new sales that our clients have, cost reductions, job growth, and also product and market growth. So when they, after we do a consulting service or a workshop or an on-site training, then we ask the business to fill out a survey, and then that's how we get graded by NIST, because we are part of the National Institute of Standards and Technology. The MEP centers are funded by NIST, which is a government subsidy. So that's a little bit about Purdue MEP in a nutshell. All right, so now we'll start with the core tools. All right, so the 5 quality core tools that we're going to be going over very briefly are APQP, Advanced Product Quality Planning, and then we have the PPAP process, which is Production Part Approval process. We're going to touch on FEMA. Now there is a new FEMA edition. What I'm going to show you is the existing 4th edition FEMA. I'm going to just briefly mention the new version that's out. And then we're going to talk about measurement system analysis and end up with statistical process control. As part of APQP, the first topic there, we also are going to talk about control plans. Okay, so AIAG, the Automotive Industry Action Group, developed these quality methods or tools so that there would be some standardization within the automotive industry. AIAG considers these to be the building blocks of an effective QMS. So as we go through these descriptions and just previews of the 5 quality core tools, you'll see how they really and truly are building blocks for an effective quality management system. So not only are they used in automotive now, but they are also being rolled out in aerospace, defense, and medical industry as well. Okay, so the first one we're going to talk about is APQP, Advanced Product Quality Planning. And included within the APQP guidelines book is a section on control plan. So the APQP guidelines were first developed in the late 1980s, and they were used again to standardize supplier quality systems. AIAG and the automotive segment wanted to standardize the way their suppliers were providing information to them. So this was one effective way of doing that, was by publishing these guidelines so that everybody could do things the same way. So advanced product quality planning is a structured method of defining and establishing the steps necessary to assure that a product satisfies the customer. Okay, so it's just putting some structure into place. So there's set stages throughout quality planning. And, you know, at the end of each one of these stages, you're going to have a gate that you have to cross over. So before you can go into the next one. So it's just a step-by-step structured method to making sure that the requirements that you're getting from your customer are getting met. And then the ultimate goal is to facilitate communication with everyone involved so that all required steps are completed on time. So APQP is a method to improve communication within your organization, and also including your customer and perhaps even your suppliers. A good APQP program, you're going to include your suppliers as well as your customer. And then, so with this open communication, you should be able to meet those requirements on time. So we want to be effective and we want to be efficient. So APQP is used in two ways. So you can do APQP for a new product, or you can do APQP for a product or process change. You know, for a new product, maybe you go through, your checklists are just greater in length. Maybe, you know, there's more things you got to verify and prove out and validate. Whereas with a product or just a process change, those checklists might be just will be minimized. But you're still going to go through the same steps, the same methodology. So basically, there's 5 steps in the APQP process. The first one is planning. Making sure your customer's needs and expectations are clearly understood. So getting all that information up front from your customer so that you can plan out the project. And then the second step is product design and development. Okay, so getting the information from your customer and then putting together designing doing the product design. Sometimes if you're not design responsible, this step can be skipped. Because you're not design responsible, but you should get get some of that information from your customer. So like a blueprint or part drawing, that's part of the product design and development. It just happens to be that your customer would do the design and development of that part. But then the next step then, process design and development, that's where you would do most of the work on, you know, your organization would get more heavily involved. This is making sure that you have designed a manufacturing process to make the product that the customer has designed, or perhaps maybe you did design the product. So coming up with a process design to manufacture the product that you designed. And then the fourth step there, product and process validation. That's when you're verifying and validating that your product and process meets the customer requirements and that the process and the product works as it's supposed to. And then the fifth part there, feedback, assessment, and corrective action. It's just, you know, once you go into production, you've implemented your product and process design, and then, you know, get feedback. How is it working? How is it running? Do we need to make improvements? So the cycle just, you know, starts over again. So looking at this diagram actually comes from the APQP manual or guidelines. And it shows how all 5 of these steps kind of work together. So you start off with the planning, and then the product design and process development. They can start at the same time. Usually your product design and development will start first. And then towards the end is when the process design and development, but they kind of go hand in hand. And then you have your product and process validation, then you go into production. So you can kind of see how this whole system is supposed to work. So some of the benefits of APQP then, as I mentioned earlier, it facilitates communication and collaboration. All right, so not just internally, but with your suppliers and your customers. It involves a cross-functional team. So when you do an APQP project, or you implement APQP, you need to be getting Everybody throughout your organization, every function should be participating at some point within the project. Marketing, product design, manufacturing, purchasing, department managers, supervisors, operators. At some point, you'll probably be drawing in, you're going to have a core team with perhaps sales, engineering, quality, and then, you're going to have a core team. Program managers are usually in this core team. And then as you go along and you progress through each of those 5 stages that we showed here, then you may add in people as you need them from production. But it's always good to have production representation and quality representation up in that early planning stage, if at all possible. So another benefit is ensuring voice of the customer is understood and directs resources to satisfy the customer. It also promotes early identification of required changes. So as you're going through this project planning, implementation, you're going to come across issues. So these issues, if you didn't use APQP, you wouldn't find out about these issues till you were already in production. So it's better to find them out ahead of time than it is once you've got 30,000 pieces sitting on the shelf and there's something wrong with them. So it's just better, the sooner you can find out these issues, the better off you are. And then as the ultimate goal here is it results in a quality product on time at the lowest cost. So we really push getting a quality product out the door on time. Okay. So in summary then, for APQP, what we do is we perform upfront detailed quality planning using those 5 stages as discussed in the APQP guidelines, which results in quicker product launches, fewer defects, and increased customer satisfaction. So whatever we can do to make the customer happy and give them that warm, fuzzy feeling, the better off we are, which will lead to a better relationship with your customers and hopefully more business in the future. So part of the APQP guidelines, in the back of that book is a section on control plans. So again, the first statement there is the same for all of these quality core.
Hey, Sharon.
Yes.
I am so sorry to interrupt.
No problem.
Are you able to, because you have host controls, are you able to look at the waiting room to see if there's anybody else waiting to join the meeting?
Oh, you know what? I had 3 people. It said 3 people waiting. I thought you were still in control. Let's see here. Oh wait, there it is. See waiting room. Admit all. There, we got 3 people coming on board.
Thank you so much. That
I'm
should
sorry.
be the last of them. I can't imagine we would have any others.
Okay, okay.
Thank you.
All right, no problem. Thanks.
Bye.
Bye-bye. Okay, let's see here. All right, so now going on to control plan. So what is a control plan? It's a control plan, but this is a definition out of the book. It's a written description of the systems used to minimize process and product variation. So that's what the intent of the control plan is, to minimize process and product variation. So if we do things the same way every time, we're going to minimize process variation and product variation. The product variation is going to come by making sure that you're not only just doing your checks the same way, but any kind of other, you're doing your setup, you're actually running the part the same way, handling it the same, putting the same order. You're doing everything the same way every time, and this will reduce process and product variation. So I don't know if you've ever heard of it, but control plans are living documents. So living documents means that they can be updated as needed. However, in the automotive industry, if you update your control plan, you should at least tell your contact, your customer contact that you're updating the control plan. They need to see it. Sometimes they have to approve it if there's a safety critical feature designated on the part print. then you would have to get approval before you update it. But you can still update your control plan. You just have to make sure you let your customer know that you're updating it. And then the note at the bottom, that control plans do not replace detailed operator instructions. You still should have operator instructions available, because the control plans are just telling you what checks you need to do. May or may not tell you exactly how to make or manufacture the product. So this is a generic control plan template. Let's see, let's go to the next slide, sorry. So in the control plan itself, there's an area where you identify your characteristics that you want to control. And then there's a methods section that tells you how you're monitoring and measuring those characteristics, or control methods, we call them. So the first one there, it says good welds, no visible defects. So that's a visual, that's a visual evaluation on the weld, and it's just visual. So how do you control that weld then? The process characteristic, which is weld voltage, that will state how you're going to control the product characteristic of a good weld. And then over in the methods side, you're going to state what the tolerance is, or the specification, and then whatever evaluation or measurement technique you're going to use, a sample size, so how often, how many, how often, your control method, and reaction plan. The reaction plan is very important, because if one of these dimensions or characteristics are out of specification, the operator needs to know what to do about it. So that reaction plan should be detailed enough, reference another document so the operator knows what they need to do. If you don't have room in that area to write it all in, what you need to do, then it should at least reference another document so they know what to do. So here's some benefits of the control plan, using control plans. And it is a requirement for the IATF 16949 that you do use control plan. So quality then, it reduces waste and improves product quality. It identifies sources of variation. You're going to have better customer satisfaction because you're doing the same things the same way every time. Process knowledge provides a summary of process knowledge, some organizational knowledge perhaps, because it provides a summary or a history of what you've done. Because if you keep a log or you track the changes that you've made to your control plans, it's a very good method for keeping the history of that particular process documented. And then again, it is a living document, so it's a very good communication tool. So there are 3 types of control plans. Prototype build control plans are used when you're doing product design and development. Pre-launch control plans, most automotive OEMs require pre-launch control plans. And this would be developed during the process design and development. And then your production control plan, that's what you would submit in your PPAP, which occurs during product and process validation. And then as part of production, then that production control plan would be instituted in production. Now with pre-launch control plans, some customers require you to use your pre-launch control plan for a certain amount of time after you've been in production. I know GM used to require you to be it just varied from plant to plant. Some plants required you to be in production for 3 months, sometimes 6 months. And then you always had to ask to stop using the pre-launch control plan. You'd have to send them data, and then they would take you off of the pre-launch control, or take you off of pre-launch status. So then you could, then you would start using your production control plan. But that just varies from customer to customer. I was just giving you an example of how GM used to do it. So how do you control your control plan? Is your control plan being followed? Are error proofs functional? Is the plan practical and feasible? Is the plan current, and is it really your strategy? So these are all questions you should ask just to make sure that your control plan is working the way it should be for you. Okay, now we're ready to move into PPAP. So again, there is a blue book, black and blue book actually, the AIAG has published for PPAP, and it is the 4th edition. This book also has guidelines for specific requirements for bulk materials, such as those that is listed here: adhesives, sealants, chemicals, fuels, and glass. Also for tires, and also for truck OEMs. So in this guideline, it separates some of those requirements out for bulk materials, tires, and truck OEMs. And again, these AIAG manuals, for those of you who aren't familiar with them, you can go to that website there, www.aiag.org/store, and you can order these guidelines for price, of course. Very nice price. Okay, so PPAP. By definition, this is a standardized process that helps manufacturers and suppliers communicate and approve production designs and processes before, during, and after manufacture. So not only do you submit your PPAP to your customer, but you should also be having your suppliers submit their PPAPs to you before they start shipping you product that you want to use for production. It's used in automotive and aerospace industries as well. So those are the 2 primary industries that PPAP's used. So some of the benefits then, again, reduced variation in the manufacturing process. It also helps you find issues before they occur. When you go to lay out the part and do the dimensional layout, you find a dimension that's wrong, out of spec, so you have to adjust your tooling or you have to do something different. But if you wouldn't have gone through this PPAP process, you wouldn't have identified that issue until you were in production or made your first production shipment. So there's definitely several good benefits for doing PPAP. And then you end up with improved product quality and increased customer satisfaction. Because your customers get a chance, by doing the PPAP process, your customers get a chance to review the dimensions, the process specifications, the material certifications, as there's a whole list we're going to get to here in a little bit. So they get to review all the information regarding that process and the part to make sure it meets their requirements and it works for them. So that's the validation part. You'll send them samples. They'll get samples so they can try it in their process to make sure it's meeting the intent that they had designed. So mandatory PPAP submissions in the automotive industry are for new parts or products. And then also when you did the initial PPAP submission and there was something that was out of specification, then you could do a correction on a previously submitted part. So that's another type of situation where you would definitely have to do a PPAP. Or anytime there's been a product modification or a product change, process change, or engineering change, then you would also have to re-PPAP that part. So before you can ship your first production shipment, you have to get PPAP approval from your customer. You have to get it in writing, whether it's they sign the warrant or they send you an email. You have to get PPAP approval before you can ship your first production shipment, unless they give you a waiver. And that can be by means of an email as well. So where does PPAP fit into the APQP product quality planning cycle? So the PPAP is right there in that red box. So product and process validation. That's when you need to be able to complete your PPAP towards the end of that process and submit it to the customer. So here are some of the PPAP requirements. You need to have your blueprint or your drawing. A ballooned blueprint or drawing is usually required. I don't know if it's required it's ballooned, but it makes it a whole lot easier if you have, more than 10 or 15 dimensions on your print. If you balloon that, put a number by each one of those dimensions so that you can carry, so you know exactly where the dimensions are on the print that you're talking to and you're talking about in your dimensional layout. Any changed or engineering change documents, that goes in your PPAP. Your design FEMA, if you have it. If you're not design responsible, then you don't need to put the design FEMA in the PPAP. You're going to have a process flow diagram, a process FEMA control plan, any measurement systems, analysis studies, dimensional results, records and material performance tests, initial process studies or capability studies to see if your processes are stable and in control. Qualified laboratory documentation. So do you have your any external laboratory certifications that you may have used, your own laboratory certification? If you have any appearance items, you would have to provide an appearance approval report. But if you don't have any of those types of items listed or designated on the print, then you obviously don't need an appearance approval report. You'll need sample production parts to send with your PPAP to the customer. Then a master sample. This is what you would keep as your golden sample, so that if you ever have an issue in the future, 2 or 3 years down the road and customer doesn't like the part anymore, you can pull out that master sample and you can see if it's changed. What you have now is the same as that master sample. That comes in very handy. And then checking aids, any fixturing that you might have, that would be something you would keep there. Records of compliance with customer specific requirements. If any of your customers have something specific they want you to include in the PPAP, that's what this category would be for. And then, of course, last but not least, the part submission warrant. Okay. So once you get all your documentation together, you've done your capability studies, your MSA studies, you got all your certifications from your suppliers and your laboratory certifications, then you can put the you can finish the PSW or part submission warrant and submit the whole package to the customer. So this part submission warrant, there's several, it's just a one-page document and it's like the cover letter to your PPAP package. It tells you who you're sending it to, the organization, your part number, the customer drawing number and revision level. That's very important for traceability. The reason for submission, requested, why you're submitting it, what level. We're going to talk about levels here in a minute. And then you sign it and date it. You also need to put in there what rate you did. You have to do a production trial run and what rate were you able to meet for this particular process or product. And then at the bottom is a place for the customer to sign off on, and they can approve it, reject it, or give you the other box is usually for a conditional approval. And if they give you a conditional approval, they're going to give you an approval to ship parts for a certain amount of time or a certain quantity of parts. Usually it's one or the other, but you'll still have to resubmit your PPAP to get full approval in the future. So I was talking about levels. So PPAP has 5 submission levels. Level 3 is default. So that's if they don't tell you what level they want you to submit, then you're supposed to refer to level 3, which is doing your PSW. You send them product samples and the entire PPAP package. But regardless of what level you submit to the customer, you still have to keep the rest of the documentation on file. For like level 1 there, it says warrant only. Just because it says warrant only doesn't mean you don't do everything else. You still have to have the rest of the PPAP submission on file. So in summary then, you get you complete all the PPAP requirements that your customer tells you to do, that you need to do, and then you submit the PSW and the PPAP to your customer for approval. Once you get approval, then you can start making production shipments. Okay, so now we're ready for FEMA. So failure modes in FMEA. So a failure mode is the way a component a subassembly, a product, input, or process could fail to perform its intended function. So something that can go wrong. How can something go wrong is what we're looking for here. We're not able to perform what it's supposed. It doesn't do what it was supposed to do, a failure mode. So if you look at the actual definition, it's a structured approach used to identify ways in which a product or process can fail. So it could be either one, product or process. It estimates the risk associated with failure modes, and it identifies and prioritizes actions that should be taken to reduce risk. Now, I mentioned earlier that there is a new version of FEMA available. Actually, the 4th edition for the AIAG has published, they published it in 2008, is actually still the current revision. The new handbook that's come out, it was published last year by AIAG and VDA. So that's the German, like the German version of AIAG for the United States. So they came together and created a new failure mode and effects analysis handbook, okay? The 4th edition, there is no 5th edition. It just stops. So, and then they started a brand new handbook because the methodology, the steps that it takes is not completely different, but there are a lot more steps involved. The FEMA version that we have now is just one small portion of what the new FEMA will look like. Okay. But regardless of which handbook you use, these benefits of FEMA and also what I talked about here on failure modes, and one of the failure mode is all this information is still pertinent to the use of the new handbook. That's what the new handbook looks like. All right, so benefits of FEMA. It identifies and eliminates potential issues early in the development of a process or product. So by finding out what these issues are early during product design or process design, the intent here is to design them out. So you can get ahead of it and either design them out or build in detection or prevention controls so that you can prevent failures from escaping your facility. So there are 2 types of FEMA. There's design FEMA and process FEMA. So design FEMA focuses just on that, design issues, and then the process FEMA focuses on manufacturing or assembly issues. Okay, so design FEMA fits into the product life cycle, product planning cycle during the product design and development. That's where you would start working and developing your DFEMA. And then your process FEMA would be initiated in the process design and development stage. So for the 4th edition AIAG FEMA, this is the 10-step process that you would go through when going through the FEMA and developing a FEMA. And then so the new handbook, FEMA handbook, has about, it's a 7-step process, but there's a lot of information that has to happen in each step of those processes. It's a little bit more complex. So rankings, severity, you use a severity ranking. This is part of the risk analysis and risk evaluation. So how does a failure affect the customer? That's the severity. And then occurrence, you have to give it an occurrence rating. How often is the failure likely to occur? And then you have a detection rating, which is how well do the process or product controls detect the failure or the cause of the failure. Okay, so detection is all about the cause of the failure. How can you prevent the cause of the failure? How can you detect the cause of the failure or detect the failure? So each one of these rankings is measured on a scale of 1 to 10, and then you combine them to get a risk priority number. And depending on, so an example of these risk priority numbers, it's just simple math. You just multiply multiply them out. 6 times 2 times 5 is 60. So that would be an example of how you would come up with a risk priority number. Okay, so the 4th edition FEMA guidelines, the AIAG FEMA guidelines, the template that's used for that looks like this. So you have an area in the first section to identify your failure modes and their effects. So you list the process step, what's the requirement of that step, and then what could potentially go wrong. So if you have a dimension, it could be undersized or oversized, and what's the effect of that failure mode on your customer or on the end user. It could be what's the effect on the next operation. Then you would assign it a severity number. The next group of columns helps you identify the cause of the failure, so you can add in an occurrence rating. And then you list your controls, and then you give a detection rating based on those controls. And in the AIAG handout, there's criteria, so you know what rating to give severity. So like on a scale of 1 to 10, you'll know which number to select based on the effect of the failure on the customer. Same thing with occurrence. On the scale of 1 to 10, there's criteria in the FEMA guidelines that will tell you what number you should select based on how likely that issue or that failure could occur. And then same thing with the detections. There's a chart for detection, so you'll know, it gives you a good idea of what number to select. And then the RPN number is just a method for helping you prioritize which failure modes you need to take action on to reduce the risk, likelihood of a defect escaping your facility and getting to your customer. And then this template also gives you a method for tracking your actions, who's responsible for doing them, and were the actions effective. So you would reevaluate your severity, occurrence, and detection numbers and redo your prioritization. That tells you if your action items were effective or not. So some key points then. FEMA's are living documents, as we mentioned earlier about control plans. FEMA's are living documents as well, so you want to keep them updated when you change something. If you have a corrective action that required you to change a control, or maybe you added something to the process, then you would want to pull up your FEMA and reevaluate the failure modes. Okay. And another thing, when you're first starting off doing your FEMA, make sure that you get everybody involved. It should be a team effort. You don't want to do a FEMA by yourself. It'll be nothing more than just pencil whipping something. You need to get everybody involved to get the value add out of the FEMA tool. The FEMA for one project will likely be reviewed for other projects. So once you have a FEMA developed, you can take some of the same strategies, concepts, lessons learned from that FEMA and apply them to a project in the future. Okay, so now we're ready for MSA, Measurement Systems Analysis. So there's the black and blue book there that AIAG has published for MSA. There is a requirement for MSA for measurement system analysis in the IATF standard. It says statistical studies shall be conducted to analyze the variation present in the results of each type of inspection, measurement, and test equipment system identified in the control plan. So for each gauge method or any kind of measurement system you have listed in your control plan, you have to do statistical studies for that system or that gauge methodology. It says analytical methods and acceptance criteria used shall conform to those in reference manuals on measurement systems analysis. And then you can always use other analytical methods that is approved by your customer. Okay, so measurement systems analysis is a method that uses scientific tools to determine whether a measurement system is adequate for a given application. Okay. So we use MSA before collecting data from the process to analyze process control. And we also use MSA to confirm that measurement system measures consistently and accurately and adequately discriminates between parts. So it's accurate and it has enough built-in accuracy to discriminate between parts. And a good measurement system has low variability and truly reflects the process. So total variation from your process or total variation of a measurement system comes from process variation and also from your measurement process. Okay, so we want only common cause. We're going to talk about common cause and special cause. Those are the two types of variation that you're going to have in process variation. So we'll talk about that a little bit when we get to SPC. But just for this, process variation and measurement variation makes up your total variation in your measurement system. So gauge R&R is a very common methodology used, or a very common statistical tool used for MSA. This evaluates your ability to measure the product accurately and consistently. And it takes into consideration the product itself, the person taking the measurements, the actual measuring equipment, and the environment. So it takes all those 4 different types of variations, and all of that is used to calculate your gauge R&R. So again, gauge R&R, or gauge repeatability and reproducibility, is used to measure the variation in your measurement system, not just the actual gauge that you're using. All right, so repeatability is variation in measurement obtained with one measuring instrument when used several times by the same operator, and then when measuring an identical characteristic. So you're using one specific measuring instrument, you're using one operator and one specific part, or one specific characteristic on the part. That makes up repeatability. And then reproducibility is variation in the average of measurements. So this would be one measuring instrument, one specific dimension, but multiple operators, multiple people taking different measurements, taking several measurements. That's reproducibility. So why do we need to conduct gauge R&R? So we can make sure we have all processes. We know that all processes contain variation. That's just a given fact. So we want to make sure that we can see how much variation we're getting in the measurement process. Some variation comes from the person taking the measurement, and then the measurement process, the gauge itself. So we want to capture all that variation. So the output. So when you do a gauge R&R test, we want to make sure that your percent variation is ideally under 10%. We want your percent variation to be under 10%. And then if there's anything between 10 and 30, then it may be acceptable for some applications, but your customer probably will not allow that to happen. And anything over 30% variation, you're going to have to figure out which one of these 4 areas you need to eliminate some variation from, because it's adding to your total system, your total measurement system variation, and causing your total, percent variation to be too high. So by looking at the product, maybe so there is something that's out of spec, or maybe it's shifted in one side, or your measurements are skewed. So maybe it's the measuring equipment. You just have to look at every single option there and see where you can reduce some variation. And then the 5th quality core tool is SPC. Here is the AIAG guidelines for SPC. SPC stands for Statistical Process Control. So this uses statistics, which is numbers and data, to measure and control the quality of a process. Yeah. So SPC and MSA kind of go hand in hand. We talked about variation in the, or process variation when we were talking about MSA a few minutes ago. So we also have, when you talk about SPC, you also have variable data and attribute data. So variable data is an actual measurement. For example, the size of something in length or width, like a length or width, it's measured in centimeters, millimeters, inches, grams, or weights in grams. It's also known as continuous data. And then you have attribute data, which is, you know, good, bad, yes, no, pass, fail. So you don't have an actual number, a specific number, but it's just, it's either good or bad, yes or no, pass, fail. And then count data, for example, the number of paint chips per unit. So if you're counting something, that is also considered attribute data too. And it's also known as discrete data. So process variation. So in a process, variation is always present. You're always going to have some kind of process variation, and it can be measured. So the causes of variation can be important. It could be you're going to get variation in a process from measurement methods, from people, from methods, processing methods, from machines, materials, environment. So any of these 6 items here can give you variation within a process. So there are 2 types of variation. There's common cause variation. This is normal variation in a process. It cannot be eliminated. This is you know, variation that's inherent within the process. You can't eliminate it. But then on the other hand, there's special cause variation. So this variation is from something different or unusual. So maybe you have a coil change or you change lots of material. So that's going to be a special cause variation. An assignable cause exists for the variation, and the assignable cause can be eliminated or addressed. So anything that is something different in the process will cause a special cause variation. Could be changing shifts. A different person is running the job. I mean, it's the same flow, but maybe another person comes along and starts running it. So that's a special cause variation. So we try to capture this variation by using a control chart. A control chart is a type of chart used to show how a process changes over time. So you can see trends in your data. So the purpose of the control chart is to find, identify, and correct problems, predict expected outcomes of a process. It will also help determine whether a process is stable, if you know the 8 rules for being in control and out of control. Analyze variation, and it can determine where to focus your improvement efforts. Okay, so control limits. So control charts have control limits, which are those dashed green lines there. And then you have specification limits. The specification limits are it's the specification or tolerance for that dimension that comes from your drawing. So the spec limits typically fall outside the control limits. That's the whole plan anyway. You want the control limits to be tighter than your upper and lower specification limits. So if we compare control limits to specification limits, control limits are used to determine if the process is in a state of statistical control. And those control limits are calculated from the data points that you enter. This is what we call the voice of the process. Whereas specification limits, these come from the drawing, they're the customer requirements, and we call these the voice of the customer. So control limits are calculated from your data, they come from the process, the voice of the process, and specification limits are the voice of the customer. Think of it that way. So the ultimate question then for SPC then is why measure and control quality? So why do we measure and control and attempt to control the quality of processes? So if we have good quality, We're not going to waste time making scrap parts. We're not going to waste time reworking parts or repairing parts. Our customers are going to be happy. We're not sending them, they're not calling us once a week because they have a quality issue that they want you to come sort their parts for. So we stop products. First thing to do is to prevent the defect from happening. Second thing to do is to be able to detect it. And then thirdly, we want to try to control the process so that the defects don't happen at all, or we can control that. So that's the whole point of why we want to measure and control quality. So that completes my presentation. If you would like any other, your companies, or you would like to, are interested in any of our other training sessions, as I mentioned earlier, I specifically do ISO 9001, AS 9100, and IATF 16949 implementations, internal auditor trainings. But we also have another whole team of experts that work on productivity improvements, which aren't listed here. So we do 5S training, value stream mapping. Let's see, and then we have leadership courses as well. So we have a whole gamut. So if you're interested in anything, you can find us on the internet at purduemep.org, or just Google Purdue MEP, and then that will pull us up. If you do have any further questions though, you can contact the quality lead service manager at Purdue MEP, and there's his address there, email address or phone number. And that's all I have for tonight. Thank you for letting me present tonight. I appreciate it.
Thank you, Sharon. Do you have time to answer some questions if we have a few?
Sure.
Okay, I'm gonna go ahead and take control back, but we've got our first question up here in the chat box.
Okay.
Asking if you do a GRR on each gauge or just on every type of gauge, like one GRR for all the 6-inch calipers, for instance.
Okay, you can do on the type. You don't have to do on every single caliber. You can lump those two families.
So you could do one for all the 6-inch calipers, and
Yes.
then maybe one for all the 12-inch calipers.
Yes, exactly. Right. Mm-hmm. Yep.
Okay. Okay. So if anyone else has any questions, you can enter them in the chat box real quick there. We'll kind of hang out here for just a few minutes and try to answer those. And if not, we thank you for joining us tonight. Again, if you would message the host if you need a statement saying you were in the meeting, or you can email one of the leaders of ASQ Lafayette section. If you're in this meeting, you probably got an invitation with information about the meeting, and our emails are included in that information. Looks like we have another question. Does everything on the FMEA have to be OBJ, the control plan? I'm not sure what they're asking here.
I can't see the chat box. Say that one more time.
Does everything on the FMEA have to be, I think they're asking, it has to be in the control plan or covered in the control plan?
Yeah, because they're linked together. So for each process step, the flow chart, the process flow diagram, the FMEA, and the control plan they'll all be linked together by step in the process. So if you have each step in an assembly operation, so the first step would be setup, then there would be a setup in the flow diagram, a setup line in the control plan, and a setup in the FEMA.
Okay. On the control plan, would it be correct to just put weld as the characteristic? Or do we need something a little more specific there?
You would have to put, depends on what you're doing. Are you wanting, you have to be more specific. Is it a weld length, a weld depth, penetration depth, or is it just a visual? You need to be specific, because otherwise that determines what kind of evaluation method you're using to measure it.
So you're looking for a specific characteristic, not just a
Yes.
general. Yeah, very good.
Yes. Mhm.
So the next one I can answer, getting a copy of the PowerPoint. Our first attempt is going to be put that up on the My ASQ page for the Lafayette section. Failing that, if that's not working, then we will go back and try to find everybody that attended this and make sure we get copies of that PowerPoint out to them.
Okay.
We really want to start relying on that My ASQ page to the extent that we can. So that's going to be our first attempt.
Okay. If nothing else, I can send, I'll check if I can do that for confidentiality. Otherwise, I think I could probably send a PDF version. I don't know if they'll let me. I have to ask.
Okay. And let's see, we got another one coming here. Okay, from our, just a note to everyone that's here, from our secretary, if you are asking for a statement that you're in a meeting, please include your screen name so that we can verify screen name versus email. And we got another question for you, Sharon. Is there any charge to Indiana companies for using the Purdue MEP support?
Yes, there is. We charge for our services. The only one that doesn't have a fee is if you do a TAP 40 project. What that involves is a 40-hour, you get 40 hours of service for a specific issue, okay? So maybe you have a rust issue and you want to reduce the rust in a department or on a specific part. So it's a very specific issue. But all of our other services that I listed on the chart, yes, we do charge a fee for. But you'll find out that it's usually less to go through us than to go through like a BSI or QAI training. Our fees are usually a little bit less than those.
Right. So just my own 2 cents there. Gertz Industries, where I work, has used Purdue MEP for a couple of projects, and we found the consultants that are sent to help us are very knowledgeable, very good at what they do, easily comparable to any of the big name consultant groups out there. And yes, the fees are pretty comparable. So just my 2 cents in there.
Thank you.
Anybody else have other questions? One comment here, my company used MEP for Six Sigma black belt training, and it was great.
Thank you. Who was your trainer or instructor?
If we get an answer to that.
Mike.
Mike somebody.
Yeah, probably Mike Weisman. Yep. Yeah, he's a good one.
All right. Any other questions? I don't see anything else coming in at the moment. Okay.
So Tom,
not seeing any other questions coming up.
Yeah, Tom, I'll send you an email. If I can give you that the presentation. Okay.
That would be great.
Okay.
All right. If there's no other questions coming in, then I guess we're going to go ahead and sign off here. Sharon, I want to thank you for your presentation. We do appreciate it. The Lafayette ASQ will send you a little gift card in appreciation for your time. So we'll make sure we get your mailing address and be looking for that in the mail. And again, if anybody knows someone or wants to do some presentations yourself, we're looking for December and then again in August. We usually take a break over the couple of summer months there. But if anybody's looking to present, reach out to the leadership of the Lafayette section and we'll happily take you up on that. Thank you, everyone. Have a good evening, and we look forward to seeing you at the next meeting.
Thank you.
Bye-bye, everyone.
Thanks so much.
Thank you.